So in this video, I am going to explain about organic compounds containing CHO, that is alcohols, phenols, ethers, aldehydes, ketones and carboxylic acids. So we'll discuss one by one. So these are worksheet questions of organic compounds containing CH and O. So first question, here it is given aldehyde, this aldehyde group, and this will be ester group. So here NaBH4 is given. NaBH4 reduces. NaBH4 is reducing agent and it reduces aldehydes, ketones, acid halides. It reduces only aldehydes, ketones and acid halides. So mild reducing agent. So in given example, aldehyde group. So this will be ester group. COOME, ester. Next. Here CH2, CH2, CHO is present. CH2, CH2, CH4. So NaBH4 reduces only aldehyde. Only aldehyde will be reduced. Aldehyde. So aldehyde will be reduced to corresponding alcohol. COOME. Ester remains as it is. It gives CH2, CH2 and CH2OH. So which is primary alcohol. Therefore option D. NaBH4 reduces only aldehyde group but not ester. Selective reduction. See, aldehyde group will be converted to alcohol like this. Remember like this. This is aldehyde. NaBH4 reduction. So dissociate only pi bond and add here H and H. It will be converted to CH2OH, primary alcohol. Dissociate only pi bond. So option D. Next. The major product in the following reaction is. So here it is given bromocyclohexane or cyclohexyl bromide. So first reaction with Mg. Mg means Grignard's reagent will be formed. That is MgBr. So after that CO2. So this is delta minus and delta plus. Right here. Next here Grignard's reagent, Mg becomes plus and this total becomes minus. So this minus attacks electron deficient carbon. So therefore linkage between C double bond O minus, MgBr plus, intermediate compound. So which on hydrolysis gives here add H plus and here OH minus. It will give COOH, cyclohexane carboxylic acid. Next, this will react with SOCl2, thionyl chloride. Here OH will be displaced with Cl. That means it gives COCl, which is acid chloride. Next, after that CH3 twice dimethyl cadmium compounds. Similar to that of Grignard's reagent, this can liberate CH3 minus. Here CH3 minus will be there. That minus displaces Cl minus. Therefore, final compound will be here C double bond O CH. So here option B. This is major compound. Here Cd plus and CH3 minus nucleophilic substitution SN2 mechanism. The next question. Among the following compounds, the correct order of acidic strength. These compounds are given. So last compound is alcohol and the first three compounds are carboxylic acids. So carboxylic acids are more acidic. Carboxylic acids more acidic than alcohols. Acidic nature. So here carboxylic acids, three types are given. First one CH, triple bond C, COOH. Next CH2 double bond CH, COOH. Next CH3, CH2 COOH. And at the last CH3 CH2OH, which is primary alcohol. Here COOH group is attached to sp carbon, which is more electronegative. That means simply minus I effect will be more. If COOH group is attached to minus I groups, that will be more acidic. Next, this carbon will be sp2. This is also more negative. This carbon sp3. So here just alcohol, no need to write. So clearly this will be the acidic strength. So sp carbon is more minus I group. Therefore that will be most acidic. Therefore option 1, 2, 3, 4. Option A. If COOH is attached to minus I group, that will be more acidic. sp carbon is more electronegative, that is more minus I group. Next. The intramolecular hydrogen bonding is present in. So intramolecular hydrogen bonding means hydrogen bonding within the same molecule. It will be like this. I am checking fourth option, 2-hydroxybenzoic acid. 2-hydroxybenzoic acid. So here delta plus and delta minus. So between these two, hydrogen bonding is present. So this will be intramolecular hydrogen bonding. So here due to intramolecular hydrogen bonding, there will be formation of ring. So this will be known as chelation effect. Chelation effect or ring formation. Chelation effect is observed in case of intramolecular hydrogen bonding. So this will be also known as orthohydroxy benzoic acid or salicylic acid. So very important option. In remaining molecules, intermolecular hydrogen bonding is possible. So for the formation of intramolecular hydrogen bonding, the groups must be at ortho positions to each other. Next. So ammonia and its derivatives of the form NH2Z undergo condensation reaction with carbonyl compounds. That is correct. So carbonyl compound C double bond O. This is carbonyl group. Reacts with ammonia derivative. This ammonia derivative results in the formation of C double bond N Z compounds. So all carbonyl compounds can react with ammonia derivatives. That means first one true. First statement is correct. Next, this reaction is example of irreversible reaction. So this reaction is reversible and catalyzed by an acid. This is very important. Here this is example for irreversible is given, but this reaction will be reversible and takes place in the presence of acid. Then statement 2 is wrong. Therefore A is true but R is false. So option next. Arrange the following phenols in decreasing order of their pKa. So as the value of Ka increases, acidic strength increases. As the value of pKa decreases, acidic strength increases. Acidic strength increases with increase of Ka or decrease of pKa. pKa means minus log Ka we know. So first I will write acidic order. Ka order. That means acidic order. So here first one. So first one, para-nitrophenol is more acidic. After that ortho. After that meta. And at the last phenol. So para-nitrophenol compound D. Next orthonitrophenol compound B. Next metanitrophenol compound C. And phenol is compound A. This is Ka order. So therefore pKa order is reverse. Reverse means A, C, B and D. So therefore option A, C, B, D. B option. Next. Identify X and Y in the following reactions. So first reaction is toluene gives benzaldehyde only in the presence of chromyl chloride in the solvent CS2. CS2. First it gives intermediate compound which is chromium complex CHO Cr OH Cl2 twice, chromium complex. Chromium complex. So which on hydrolysis will give CH, OH and OH. So here, since two OH groups are attached to same carbon, water will be eliminated like this, minus H2O. Gives CHO, that is benzaldehyde. This is total mechanism. So CrO2Cl2 is chromyl chloride. So toluene to benzaldehyde. Toluene. Second reaction. CH2OH is given benzyl alcohol. Gives benzaldehyde. This is primary alcohol. So primary alcohol with copper at 300 degrees centigrade gives CHO, benzaldehyde. So both are benzaldehydes. Here also benzaldehyde. So here dehydrogenation takes place, minus H2. Minus H2. Dehydrogenation reaction. Therefore option B. In first reaction, chromyl chloride. In second reaction, copper at 300 degrees centigrade. Next. The major product of the following reaction is first compound CH3, CH2, 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 CO, CH3. So first reaction is NaOBr, NaOBr and H2O or H3O plus acidic hydrolysis. This is nothing but haloform reaction. Haloform reaction. So in haloform reaction, remember like this. So this compound will be converted to CHBr3 and the CO will be converted to COOH. That means compound will be CH3, CH2, CH2, CH2 and COOH and plus CHBr3 bromoform. Next, this on reaction with red phosphorus and Br2 followed by hydrolysis. It gives this is HBZ reaction. Alpha halogenation of carboxylic acids. Here this is alpha carbon. At alpha carbon, halogen must be substituted. CH3, CH2, CH2, CHBr, COOH. Check the compound. Option C. CH3, CH2, CH2, CHBr and COOH. At alpha position, halogen will be substituted. HBZ reaction. These two are famous reactions. First one, haloform reaction. Next, HBZ reaction. Next. Sodium tertiary butoxide on reaction with methyl bromide produced the product P. Sodium methoxide upon reaction with tertiary butyl bromide generated compound Q. P and Q are. This is also important question. So first sodium tertiary butoxide. That means compound sodium tertiary butoxide. This compound on treatment with methyl bromide. CH3Br delta minus and delta plus. So here SN2 mechanism takes place. It gives CH3, CH3, CH3 and OCH3 ether. Ether is formed. Next, second reaction. This is compound P. Sodium methoxide, that means CH3 O minus Na plus sodium methoxide reacts with tertiary butyl bromide. Tertiary butyl bromide. Here there will be no substitution reaction due to bulkiness of tertiary butyl bromide. Therefore, so first Br will be eliminated. That means here take SN1 mechanism, or we can say elimination mechanism. So first it gives tertiary carbocation plus NaBr. Next, this compound reacts with, let here, tertiary carbocation. So tertiary carbocation which is more stable. So which on treatment with, see, tertiary carbocation will be like this. It reacts with OCH3 minus methoxide ion. Hydrogen will be eliminated. Therefore, finally it forms CH3, CH3 double bond CH2, which is Q. Here P compound is ether, Q compound is alkene. Alkene is major compound. Here this will be E1 mechanism. First carbocation will be formed, after that elimination of hydrogen. So very important reaction. SN2 mechanism gives ether and E1 mechanism gives corresponding alkene. Therefore option B. Next. In the following compounds, the one that gives positive iodoform test are. Here options must be, first I will check the answer. So for iodoform test, the following structures are required. First one, CH3CO or CH3CHOH is required. Or third, CH3CHX is required. Here X may be Cl, Br, I. These conditions are required. Or fourth condition also you can take CO, CH2 and CO. These four conditions are required for iodoform test. Check options. First option not possible. Second option possible. Second option possible. Next third option not possible. Next fourth option possible. So 2 and 4. 2 and 4. See here. Remove 6. 6 option is not there. 2 and 4 only. Very, very important process, iodoform test. These 4 conditions are required. Very, very important question. So 2 and 4. So I will write options also. See, first compound is given and writing directly second compound CH3, CHOH, CH3. So due to this group, this can undergo haloform test or iodoform test. Next, fourth compound CH3, CH2, CO, CH3. So due to the presence of CH3CO, it can form iodoform. 2 and 4 only. Option D. Next. So A, B, C, D in the following reaction are. Check first one. So given compound is salicylic acid. Salicylic acid, first soda lime. That means NaOH and CaO followed by delta heating. So here CO2 will be eliminated. Minus CO2, decarboxylation reaction. It gives phenol. That is OH, phenol. That is compound A. Next. So which on zinc dust? On treatment with zinc dust, O will be eliminated. It gives benzene plus ZnO. This is compound B, benzene. Okay, next. What is compound D? Heating. Compound D, which on heating, CO2 will be eliminated again. Decarboxylation, it gives again phenol. Compound D. Next. Bromine water. So this is test for phenols. So it gives tribromo derivative. White PPT. So which is compound C. Now check option. So compound A is phenol, B is benzene, C is tribromophenol and D is again phenol. So option B. Very, very important reactions. Next. The major product in the following reaction is. So given compound is here COCH3 and here COCl, acid chloride. I am taking compound on right hand side. Next, reagent on left hand side. So reagent C2H5. C2H5 twice CD. Diethyl cadmium compound. Similar to that of Grignard's reagent, C2H5 will be minus nucleophilic. Therefore, it attacks electron deficient carbon and Cl will be eliminated. So therefore, compound will be here COCH3 and here C double bond O, again here C2H5. So C2H5, CO, CH2. So benzene ring, CO, CH3. So major compound. Nucleophilic substitution, SN2 mechanism. SN2 displacement. So C2H5 minus nucleophilic reagent that can attack electron deficient carbon of carbonyl group, and Cl will be eliminated. So option D. Next. The major product formed in the following sequence is: first benzene plus CH3, CHCl and CH3 in the presence of AlCl3. Friedel-Crafts alkylation reaction. So first it gives isopropyl benzene, so which is known as cumene. Cumene. So which on treatment with O2, that means aerial oxidation. So it gives C, CH3, CH3, OOH, cumene hydroperoxide, which on hydrolysis will give. So rearrangement will be like this. The compounds will be phenol plus acetone. Phenol. So option A. Byproduct is acetone. Main compound is phenol. So best method to prepare phenol. Next. Identify major product in the following sequence. First compound is phenol. First reaction with NaOH. It gives sodium phenoxide, O minus and Na plus. Next reaction with CO2. So delta minus and delta plus. So here compound will be like this. Resonance structure. C double bond O, here minus. So this minus attacks electron deficient carbon. Here we will get compound like this. Here one hydrogen will be there. COO minus. And here Na plus should be there. Next. This hydrogen migrates towards, and this will be like this. And the compound will be here O minus and COOH. Next, since COOH is strong acid, it can supply H plus, and it gives OH and COO minus Na plus. which on acidification it gives in the presence of acid OH and COOH, which is salicylic acid. So very very important mechanism, salicylic acid. Salicylic. Check option B. So at ortho position, COOH will be substituted. This is phenol to salicylic acid conversion. So this reaction will be known as coal-base reaction. Coal-base reaction. So option B, salicylic acid. Next, identify major product from the following sequence. First, this is the compound OH. So PCC, pyridinium chlorochromate, which is mild oxidizing agent. Here CH2OH, therefore it becomes CHO, aldehyde. Next, Tollens reagent. Tollens reagent, it will be converted to COOH, carboxylic acid, and this is alpha carbon. Next reaction, Br2, red phosphorus, which is famous reaction HPZ reaction. Alpha halogenation of carboxylic acids. Here COOH and at alpha position Br. This is alpha position. So option A. So first piece is mild oxidation. Mild oxidation or mild oxidizing agent. Primary alcohol will be converted to primary alcohol given. This one aldehyde. Next carboxylic acid. At alpha carbon, Br will be substituted. Alpha halogenation of carboxylic acids, which is HBZ reaction. Next, identify major product. First CH3, CH double bond CH2 propene, which is unsymmetrical, that reacts with HBr to form, this is Markovnikov's addition. Markovnikov's addition. So major compound will be isopropyl bromide. Isopropyl bromide. Next, on reaction with NaOH. So NaOH means aqueous NaOH. In the place, and that means in place of Br, OH will be substituted. Next, with copper 300 degrees centigrade, dehydrogenation minus H2. Hydrogen will be eliminated to form acetone. Acetone, which contains alpha hydrogens, therefore it undergoes aldol condensation. So let CH3 continuation reaction. Take 2 moles of acetone with barium hydroxide alkali and followed by heating. The compound will be like this, H2CH COCH3. Elimination of water gives alpha beta unsaturated compound. Double bond CH, CO, CH3. Alpha beta unsaturated ketone. So this will be aldol condensation. So option D. Next. Identify major product Y. So here it is given CH2Cl, benzyl chloride with magnesium ether. Grignard's reagent will be formed CH2 MgCl. So dissociation will be like this, CH2 minus. So that reacts with CO2. CO2, write like this. CO2, C double bond O, delta minus, delta plus and delta minus. Electron deficient carbon. Nucleophilic addition, it gives CH2, C double bond O minus, MgCl plus. So which on hydrolysis will give CH2, COOH. Next, after that, lithium aluminum hydride. And in the presence of H2O, COOH will be converted to primary alcohol. That means CH2, CH2OH, primary alcohol. So this is major compound. Therefore, option C. C6H5, CH2, CH2OH. COOH group will be converted to primary alcohol. Remember like this. COOH, lithium aluminum hydride followed by H2O. Dissociate like this. Here add one H and here one H. Next again here one H and here one H. So therefore it will be converted to CH2OH with release of water. So carboxylic acid will be converted to primary alcohol. So very important conversion. So option C. Next. Identify major product of the following reaction. Here OH, CH3 and CO. So this is Clemenson's reduction. ZnHgHCl, Clemenson's reduction. Clemenson's reduction. So it is acidic medium. In acidic medium, OH will be displaced with Cl and CO will be converted to CH2. Therefore, here Cl and here CH2CH3. So both substitution and conversion of CO into CH2 takes place. Therefore, option C. Clemenson's reduction. Clemenson's reduction is famous reaction to convert CO group into CH2 group. CO group into CH2 group. But in the presence of acid, OH will be displaced with Cl. So two reactions are happening here. Option C. Next. Arrange the following in increasing order of their reactivity towards nucleophilic addition. So more is the positive charge of carbonyl carbon, comma, more will be the reactivity towards nucleophilic addition. Nucleophilic addition, very very important. More is the positive charge on carbonyl carbon, more will be the reactivity towards nucleophilic addition. So more positive charge on carbonyl carbon is possible when it is attached to electron withdrawing group. Therefore, so here first fourth option should be there here. So check one by one. In fourth option, electron withdrawing group, nitro group is attached to benzene. Therefore, there will be more positive charge on carbonyl carbon withdrawing group. That is first. Next. After that, just benzaldehyde. No group is present. Next. After that, CH3, which is donating group. Electron donating group. Less positive charge is electron withdrawing group, electron donating group, and at last you can write structure like this. CO diphenyl ketone. So least amount of positive charge, diphenyl ketone. So there will be maximum amount of positive charge on carbonyl carbon if electron withdrawing group is present. That means NO2. Maximum positive charge means most reactive. After that, just here H, neither withdrawing nor donating. Next, CH3 is donating. But here in diphenyl ketone, there is conjugation between pi bonds of benzene and CO. Therefore, least amount of positive charge, least reactive. Therefore, option A. Here I have given decreasing order, but we have to arrange in increasing order. Therefore, A, B, C, D increasing order. So this is option A. CH3 is option B. Benzaldehyde option C, and this one option D. D, C, B, A decreasing order. So A, B, C, D increasing order. Next. The correct order of acidic strength of the following acidic strength. If electron withdrawing groups attached to COOH, then that becomes more acidic. If COOH is attached to electron withdrawing group, electrons will be migrating like this. Migration of electrons like this. Then it will be released. Hydrogen will be released. O minus plus H plus. So more stable conjugate base. Conjugate base. So based on this topic, check the option D. See here, fluorine is attached to, writing options, COOH, here CH2, and here F is attached. F is minus I group with triangle. After that, CH3, CH2, CHCl, COOH. This is also minus I group, but when compared to chlorine, F is powerful withdrawing group. After that, benzoic acid. So this will be also minus I group, phenyl group. After that, CH3COOH. CH3 is electron withdrawing group, which is plus I. So minus I effect is maximum for fluorine, therefore most acidic. After that Cl, after that phenyl. At last plus I group. When COOH is attached to plus I group, which is donating group, that will be least acidic. Therefore option D. So as the minus I effect increases, acidic nature also increases. Remember this point. Next. The total number of products formed in the following reaction is. So first CH3 COCl acid chloride plus CH3 twice CD should be there. Here thrice is given, twice CD dimethyl cadmium. So here CH3 minus will be there. Therefore this will attack carbonyl carbon and Cl will be eliminated. That gives CH3 COCH3, which is acetone, which is P. Next P plus CH3CHO, acetaldehyde. So first acetone, which is P, and the next acetaldehyde. Acetaldehyde. So in the presence of NaOH followed by heating, which is famous reaction aldol condensation. So here two types of aldehydes, both are having alpha hydrogens, alpha hydrogen, alpha hydrogen, alpha hydrogen. Therefore, four products are possible. So first combination of, say this is Q, I am taking acetaldehyde as Q. So what are the four products? So P plus P combination, one product. Next P plus Q combination, one product. Next Q plus P combination, one product. Next Q plus Q combination, one product. Total four products are possible. Four products are possible based on mechanism. First we have to remove alpha hydrogen. Alpha hydrogen will be eliminated from either P or Q. Therefore, four possibilities. Therefore, option B. Next. Which of the following represents structure of methyl hemiacetal of formaldehyde? So this is formaldehyde. Formaldehyde delta minus and delta plus take methyl alcohol, 1 mole of alcohol, methyl alcohol. Here this will be minus and plus. Add opposite charges. You get H, CH, here OH, and here O, CH3. So clearly CH2, OH, OCH3. Option C is hemiacetal. Hemiacetal means aldehyde plus 1 mole of alcohol. aldehyde plus 1 mole of alcohol gives hemiacetal. Next, aldehyde plus 2 moles of alcohol will give acetal. So this will be also known as 1-ether linkase. 1-ether linkase compound. Here ether linkase COC. Ether linkase. This will be ether linkase COC. Simply hemiacetal 1-ether linkase. Next, acetal 2-ether linkages. So very important these two. So when formaldehyde reacts with 1 mole of methyl alcohol, here 1 mole, it will form hemiacetal. Aldehyde plus 1 mole of alcohol is hemiacetal. 1-ether linkase compound. Therefore option C. Next. The heating of phenyl magnesium, that means phenyl methyl ether with HI. Phenyl methyl ether, or which is known as enizole or methoxybenzene with HI. HI means H plus and I minus, here O minus CH3 plus. It gives OH plus CH3I, which is phenol. An aromatic compound A. This is A. So A on treatment with concentrated HNO3 gives concentrated HNO3 gives famous compound trinitrophenol. At ortho and para positions NO2 will be substituted. This one picric acid or trinitrophenol. Trinitrophenol. Very important. So first compound A is phenol and B is picric acid or trinitrophenol. Next. So which is most viscous? Viscosity directly proportional to number of hydrogen bonds. Viscosity directly proportional to number of hydrogen bonds. So here in glycerol, there will be formation of more number of hydrogen bonds. 3 OH groups are present. Can form more number of hydrogen bondings are possible. Therefore, viscosity more. Option B. More is the number of OH groups, more will be the number of hydrogen bonds. Option B. So this one glycerol or glycerin. Very important. Next. Among the following, the products formed by reaction of enizole with HI. Enizole methoxybenzene. The dissociation will be like this. Phenoxidine is more stable. Reacts with HI, CH plus I minus. Attach opposite charges. It will give OH, phenol plus CH3I. So phenol and iodomethane. So option C. Next. This is also very important. CH3CHO, which is acetaldehyde. Delta minus and delta plus CH3MgBr, methyl magnesium bromide, Grignard's reagent. Here minus and plus, nucleophilic addition. It gives intermediate compound OMgBr, here H, and here again CH3. So which on hydrolysis will give here H and OH, CH3, CH, here OH and CH3. Secondary alcohol. Which is isopropyl alcohol. So which one? Treating with concentrated H2SO4. So minus H2O, it gives CH3, CH double bond, CH2, propene. So propene on hydroboration followed by oxidation. H2O2, OH minus. Here H2O2 must be there, O2. H2O2 and OH minus. Hydroboration followed by oxidation. H2O2 in the presence of OH minus. So this reaction is famous reaction, anti-Markovnikov's addition of water. Anti-Markovnikov's addition of water gives CH3, CH2, CH2OH. So here first compound is A, isopropyl alcohol. Isopropyl alcohol. Next one, B compound is propene and C compound is N-propyl alcohol. So N-propyl alcohol and isopropyl alcohol are positional isomers. Here option wrong is given. Positional isomers. OH group is attached to different carbons in two compounds. So position isomers. Position. Position isomers, option B. Check once. Acetaldehyde first with Grignard's reagent gives intermediate compound which on hydrolysis gives isopropyl alcohol, which is secondary alcohol. On treatment with concentrated H2SO4 followed by dehydration gives propene. Propene with hydroboration oxidation, HBO reaction. Propene undergoes hydroboration oxidation reaction to form N-propyl alcohol through anti-Markovnikov's addition of water. That means OH must be attached to the carbon atom carrying more number of hydrogens. So N-propyl alcohol and isopropyl alcohol are positional isomers. Here in option, change this option. 2 times it was given. Metamers. Say this is metamers. Therefore clearly option position isomers. Next. So which are the following on heating gives ether as main product. So ether has main product. So first I am taking benzyl bromide plus CH3O minus Na plus. So here delta plus and delta minus. P reaction. Nucleophilic displacement. SN2 mechanism. It gives CH2OCH3 which is ether. So P gives ether. Next Q. C6H5 that means C6H5 ONA sodium phenoxide plus CH3Br delta minus and delta plus. It gives OCH3 which is also ether. In remaining cases are CH3ONA O minus Na plus tertiary butyl chloride so here substitution not possible, elimination E1 mechanism. It gives CH2 double bond C CH3 alkene. So either will not be formed. Next, in case of S option, so displacement is not possible. CH3ONA plus CH double bond CHCl. Here there is conjugation between lone pair and double bond. Therefore, there is double bond character. Double bond character. Therefore, Cl will not be displaced. Therefore, no reaction. So, in P and Q, ethers will be formed. Option C. Next. The reagent which can do conversion. So, CH3, COOH, carboxylic acid with lithium aluminum hydride. It can reduce almost all functional groups. Here dissociate like this. Hydrogen and hydrogen. So first it will give C double bond OH plus H2O Again lithium aluminum hydride. Here H and here H. CH3, CH2OH. Carboxylic acid gives primary alcohol, which is ethyl alcohol. So therefore option A. Next, the product A gives white PPT when treated with bromine water. Product B treated with barium hydroxide to give product C. Compound C heated strongly to form D. The final product is. So here given cumin, isopropyl benzene. So which one treatment with O2 gives cumin hydroperoxide, and here also CH3. Cumin hydroperoxide. So which one rearrangement it gives phenol plus acetone. So compound A gives white PPT. This is A and this will be B. So compound A gives, which is phenol, bromine water, Br2, H2O, tribromophenol, aromatic electrophilic substitution, white PPT. Next, compound B. So 2 moles of acetone with barium hydroxide alkali, which is famous reaction aldol condensation, followed by heating. Aldol condensation. It gives the final compound is CH3, CCH3, double bond CHCOCH3. So alpha beta unsaturated ketone. So name of this compound 1, 2, 3 and 4. So 4-methyl pent 3 in 1 ohm IUPAC name. So very important. Option A. 4-methyl pent 3 in 2 ohm, not 1 ohm. 2 ohm. Very famous reaction. First cumin to cumin peroxide, hydroperoxide. Next on acidification it gives phenol and acetone. Phenol gives white PPT with bromine water. Next this is compound B. That gives 4-methyl pent 3 in 2 on aldol condensation. Next. The general name of compound formed by reaction between aldehyde and alcohol is. So I am taking CH3, CH, acetaldehyde with 1 mole of say methyl alcohol. So here delta minus, delta plus, and here minus and plus. So first add 1 mole. Here this becomes OH. H and here OCH3. Next take second mole of methyl alcohol. Again minus and plus. Here it gives CH3. Here H, OCH3 and here also OCH3. This will be like this. OH removal. So first compound formed is hemiacetal. Reaction between 1 mole of aldehyde and 1 mole of alcohol. And this one acetal. 2 moles of, I am writing hemiacetal here. Hemiacetal and acetal. So aldehyde plus 1 mole of alcohol, hemiacetal. Aldehyde plus 2 moles of alcohol, acetal. So final compound will be acetal. Option D. So this is the end of the chapter. In next video, we'll explain one more chapter. All the best and thank you.